When a river flows into a lake, the velocity of the water decreases. So which sediments will most likely be in the numbered location? Number 1, very close to the river. Number 2, farther away. And number 3, the farthest point away from the river itself. So a river is carrying some particles. It's carrying some large particles like you see over here. It's carrying some medium-sized particles. We're going to call those sand-sized particles. And it's also carrying some very, very fine particles like a silt or a clay-sized particles, and those are the smallest. So if you imagine and use good common sense here that this river is carrying the heavy rocks, and when the river hits the lake, the velocity slows down. So the largest particles are going to get dropped off first. And then as the river continues to flow into the lake, it's going to be able to carry the medium and the small sized particles until it's not going fast enough to hold the medium-sized particles. So it'll drop the medium-sized particles right here. And then the last thing to settle in the lake will be your clay-sized particles. So number 1, you should have drawn a line or drag and dropped large gravel to number 1, sand-sized particles to number 2, and clay-sized particles to number 3. Which substance is a mixture of organic material, which is the remains of dead plants and animals, as well as living plants and animals, and weathered rock, which is just right here, tiny pieces of weathered rock, broken down chunks of rock. So that's the definition of soil. So our best answer here is C, soil. If you wanted a little bit more of a complex explanation, soil is actually weathered rock, organic material, as well as some air with oxygen in it and water in between the pore spaces of the weathered rock and the organic material. So C, soil. In order to protect aquifers near landfills, first you got to know what that is. An aquifer is an underground water source, okay? And a landfill is where we bury our trash. Probably not a good thing to have those two things right next to each other, but if you do have them right next to each other, how do you protect them? So it says, material is placed under the soil to prevent pollution. Which property must the protective material possess? Alright, so if we've got this material right here, this geosynthetic clay liner, protecting our aquifer from this big pile of trash, what's the most important property for it? And do we want it to be high in porosity? That would mean that it would be able to, things would be able to pass through it really easily. And it's not what we want. Low permeability. That would mean that things would not pass through it very easily. So like the waste and the trash would not be able to pass through the liner and get into the aquifer. So our best answer here is B. We definitely want it to have very low permeability. Before we get to the question, let's look at this picture. Sand, which you can see right here in this diagram, allows water to pass through it very easily because it's larger grained. Silt, which is kind of a medium grain but much smaller than sand particle, will allow some water to seep through. Clay, on the other hand, is a very, very fine material, and it packs very densely and allows very, very little amount of water to pour through it, so it's low in permeability. So our question is, some ponds are designed to increase the amount of water seeping into the ground. These type of ponds will fail to work properly in locations with shallow wells. That doesn't have anything to do with it. Areas with deep surface sands. That would be the opposite. A lot of sand would allow the water to seep through like it was designed to. Soils with low permeability. A soil with a very low permeability is a soil that compacts very tightly with very, very fine particles. For example, clay. So if the bottom of your pond was made of clay, it would not work correctly if it was designed for water to seep through. So our best answer here is C, soils with low permeability. So which structure is most similar to an alluvial fan in formation and composition? Our top picture here, this is an alluvial fan. And this is where at the base of a mountain, we have a lot of sediments that are deposited. So when we have some rain and we end up with the formation of a stream as the water runs down the mountain, the water comes very fast because it's coming down a very steep slope, and it will bring rocks with it. And when the stream hits the bottom flatter part at the base of the mountain, the water slows down. And when it slows down, it drops the rocks off and it makes a fan-like projection right here. On the bottom picture, we have a river delta. Very similar structure, very similar idea here. But in this case, we have a very fast-moving body of water, like a river, hitting a slow-moving body of water, in this case, like a sea or the ocean. So, whenever that fast-moving river, which is carrying rocks through erosion, hits the slow-moving body of water, the rocks get dropped off, and it usually fans out in this type of formation right here. So which structure is most similar to an alluvial fan? The answer is a delta, A. They're very, very similar. This diagram shows you a few things. First, this is the water table. That's the level in which you would dig down into the ground to reach water. Above the water table, where there's no water, we call this the zone of aeration. And below the water table, where the ground is fully submerged and saturated in water, we call this the zone of saturation. In order for a well to be effective, you have to have the well drilled somewhat deep into the zone of saturation. Alright, so our question is, according to the above diagram, the water supply will be most consistent, meaning you'll be able to get water consistently or all the time. In well number, let's look at number 1. Well 1 is in the zone of aeration. No, we would not be able to get water out of there. Well 2 is in the impermeable layer. Impermeable means like water it does not permit water to travel through it, so there's no water in this layer. Well number 4 is way down here at the bottom, and they're daring you to pick this one, but it says up here, if you follow it, this is also an impermeable layer, which means there's no water in it. Water cannot penetrate through it. So in order to get water, we need to be in the zone of saturation, or well 3. So our best answer is H, well 3. Question 7. Organic matter in soil is made from weathered parent rock, and that's an important ingredient in soil, but it's not the organic matter. Decayed plants and animals, that's the definition of organic matter. So our best answer here is G. Decayed plants and animals is the organic matter in soil. Our soil profile on the left contains our humus, which is the organic matter, the decaying plants and animals at the top. Our topsoil, which is our very, very rich, fertile soil. Our subsoil, which here in Virginia Beach is a very tightly packed clay. Our weathered and fragmented rock. And then at the very bottom of it all, we have our bedrock. So our question is, what is located beneath the soil layers? And the best answer here is A, the bedrock. The layer in the above soil profile that has the most humus is 1, 2, 3, and 4. And humus is the organic material. That's the decaying plants and animals, and that's where you're going to find the topsoil. So layer 1, choice A, that's where you're going to find all your good, fertile topsoil and all your organic material, which is also known as your humus. So the development of a river valley. So we're going to start with a little bit of water working its way through the land and eroding out a space for a river. And then we're going to have that river get a little wider as it carries the rocks away and a little deeper. And eventually we have streams that start to meander and turn and turn. And then our final development in this diagram here is the development of a floodplain and a natural levee. Alright, so if we just look at these by common sense, which one occurs first? And, we can definitely eliminate B and D. This is a very, very well-developed river and floodplain. So now you're looking at either A or C, and which one comes first? You can see that A is less eroded away. The stream is just beginning. So our first step in the development of the river valley would be picture A. This mason jar you see in the picture is an example or a model of how particles settle. And if you take this jar and you shake it up real hard, just shake it, shake it, shake it, what you're going to see is when you stop shaking it, the heaviest, largest sediments are going to settle to the bottom very quickly. The next largest particles, the silt, will settle after that. And then your clay-sized particles will settle. And if you let this jar sit for a long, long time, even the finest of the fine particles will eventually make their way to the bottom and the water will clear up. So, in the jar shown, a sample of soil was mixed with water and then allowed to settle for 24 hours. The jar serves as a model for what process? Evaporation of water? No, because we got a lid on this jar, so there's no water evaporating. Formation of soil from parent material? This is not a formation of soil model. It's a deposition of sediment in a lake bed model. So the answer is H, deposition of sediment in a lake bed. Which of these best describes forest soil? Well, this is kind of a trick question. The word forest here is meant to just throw you off. If you just read this question of which of these best describes soil, you'd probably get the right answer really quickly. So don't overthink some of these questions. In soil, we've got like a organic layer right here, your topsoil, your rich fertile soil. Then you can see right here we've got our subsoil, our clay, and then the farther down you get into weathered rock, and eventually you hit bedrock. Alright, so what best describes soil? More rock fragments in the humus layer, which is the very, very top layer, than in the deeper layers? No, that's not going to be the best answer. More organic matter in the humus layer than in the deeper layers? Absolutely. All soil you're going to find most of your organic matter in the very, very top layer. So our best answer here is G. More organic matter in the humus layer than in the deeper layers. Which of these describes the area immediately below a water table? So remember, our water table is the level in which you have to dig down until you reach water in the ground. And remember, here's a little well in the picture, and the well must go below the water table significantly if you want your well to work consistently. It must be in this zone right here, and we call this the zone of saturation, versus this zone up here, which is unsaturated, and it's also referred to as the zone of aeration. So what's below the water table? Our best answer is D, the zone of saturation. Okay. Which layer of the soil profile would be affected the most by weathering and erosion? And if you look here at this little picture showing you some erosion, the carrying away of sediments to a new location, this is a kind of a common sense question. Which of these levels is going to be weathered or eroded first? And the answer is the obvious answer, the top. The top has to be eroded first. We can't erode the bottom and leave the top intact. So this top layer, layer 1, F, is your best answer, your topsoil. After the topsoil was all eroded away, then you might have some erosion in your subsoil. And if all that was eroded away, maybe the weathered parent material could get eroded away. And if you erode all this away, you might end up all the way down to your bedrock. But our answer is F1. Most water leaves the ocean through evaporation and returns to the ocean through? We got a water cycle question here. And remember, our water cycle is pretty simple here. We got the ocean evaporating away from the rays of the sun. And as that water evaporates, it turns to water vapor. And then eventually it condenses and turns into rain, precipitation. And as it rains down the mountain, and eventually runoff occurs, and it eventually flows back to the ocean. And this keeps going on and on and on again. That's a cycle. All right, so most water leaves the ocean through evaporation and returns to the ocean through, our best answer is A, surface runoff. Rivers springs, and aquifers are all, okay, just got to know what those three things are. A river, everybody knows what a river is, we won't go over that one. Springs, you have a little picture of a spring right here, and that's some cold mountain water flowing to a certain location. An aquifer, that's an underground water source, like in this picture right here. Sometimes you can put a well into it to get this groundwater out. So rivers, springs, and aquifers are all frozen in the winter. Okay, let's see if there's a better answer. Human-made structures, all right, located above the ground, or sources of fresh water. It's a tricky question, but our best answer here is they are all three sources of fresh water, letter J. Usually rivers do not freeze in the winter, all right? Aquifers don't usually freeze in the winter either. They're not human-made structures. Not all of them are located above the ground because an aquifer is below the ground. So that's why our only choice here is J, sources of fresh water. Under which condition would a lowering of the water table most likely occur? So what would cause our water table to go from really close to this guy's house to all the way down to nearly the bottom of the well? So we're in danger, this guy's in danger of not being able to get any more water out of his well. So what would cause that? Extended drought over the recharge zone. So let's just focus on the word drought. Would drought cause the water table to lower? All right, seems like a pretty good answer. Let's look at the other ones. Decreased runoff due to the planting of grass. There's a lot of things wrong with this one. All right, so planting of grass would not decrease runoff. All right, so and decreased runoff would mean that there's more water being absorbed by the ground, which would help keep the water table higher. So that's a bad answer for a couple reasons. Ice caps expand and cause lower sea levels. That's a really huge picture thing, and what we're really talking about here is just this guy's well. So that's not a real good answer for an explanation of just this person's well. All right, slow evaporation of heavy rainfall. So really fast evaporation of a heavy rainfall might mean that there would be a lower water table, but not slow evaporation. So our best answer here is a drought, A. That would cause the water table to slowly lower as we kept taking water out of it. Okay, the illustration on the left here shows how water and air can travel through normal soil. And remember, normal topsoil is not very compacted. It's got lots of porous space for water and air to travel through, particularly oxygen. All right? But if we have really compacted soil made of like smaller clay-sized particles, water and air have a very difficult time traveling through it. All right? So why does that happen? Why does water move more slowly through clay than through humus? And remember, that's because clay is much tightly packed. And let's look at our choices. A, clay has greater permeability. That's the opposite. Clay has less permeability. Clay has very small pore spaces. That's a true statement. Clay is very, very small in its pore spaces. It's very tightly compacted. So our best answer is B. Clay has very small pore spaces. All right. The drawing above shows the water table in the vicinity, in the proximity or nearby, a newly drilled well. Which of these drawings below shows the appearance of the water table several months later when the well has been in regular use? So here's your well, and if you start using the water out of the well, the water table might lower a little bit, all right? But that's not the only answer. When you actually take water out of the ground at a well, you end up with this little V-shaped area. All right, so the water table does not drop perfect. It ends up making this little V shape as it takes time for the groundwater to percolate or trickle through and level off. So as long as you keep using the well, you'll always have this shape, which we call the cone of depression. All right, so that V shape has a specific name. It's called the cone of depression. It will go away if you stop using the well. So A, not a good choice. B, looks like a really good choice, but that's not a good choice because it's not showing you that V-shaped pattern. C is a terrible choice. I hope you didn't pick that one. And D is the best choice because you can see that V-shaped pattern, that cone of depression. So the answer is D. All right, we have a diagram here that shows the development of soil. It takes a long time to develop soil. That's why preserving topsoil is very, very important. All right, so you start off with just some rock that gets broken down over time, and slowly some animals and some things start to die in it, and you get a little weathered rock mixed with some organic material. And then as plants and start to grow and other animals come in, you start to break down the soil even finer and add more and more organic material until eventually it settles and you have layers. You have a good topsoil and humus layer here, you've got a subsoil of clay, and then you've got weathered rock, and eventually at the very bottom you still have your bedrock. So these are our 4 stages. The question is just asking you the same thing. These 4 pictures right here, which one is first? All right, so our first one right here is number 2. And if you knew this came first, you already know the right answer. The only one that starts with number 2 is C. But just to double check, let's make sure. Number 2 would be first, and then number 4 would be next, and then number 3, and it would end with number 1. So our only choice here is C is the best answer. Okay, this question is basically asking you, can you identify the parts of the river here? And let's just look at them here. Number 1, we've got this little fan-shaped projection coming down from the mountain. And this is a little better picture of it over here. So you have fast-moving water as the rainfall, hits the mountain and the water comes together and forms little streams. This fast-moving water carries rocks down. And once that stream hits a level ground, the stream loses its velocity and it drops off all its rocks. And it usually has this fan shape, and this is called an alluvial fan. So number 1 is an alluvial fan. Number 2, this is kind of along the riverbanks here. This would be like a floodplain. So this is just a, where the river floods if we get too much rain. Number 3, this is the end of the river where it meets the ocean. And once again, this fast-moving river is carrying rocks. But when it hits a slow-moving ocean, all the rocks get dropped off, and it ends up dropping the rocks off also kind of in a triangular, fan-shaped pattern. But we call this, the end of the river, the delta. All right, so our only possible answer here is B. Number 1, the alluvial fan. Number 2, your floodplain. And number 3, right here, your river delta. Which diagram below best represents the most common arrangement of zones in a water table? All right, remember our zones. We've got the water table. Above the water table where your well would not be able to get any water, it's called our zone of aeration. Once you reach the water table, the ground is fully saturated with water, and that's called the zone of saturation. And at the very bottom of it all, we have an impermeable rock, also known as the bedrock. All right, so let's look at our choices here. What's the best arrangement? We've got aeration, bedrock, saturation. No. Aerated, saturated bedrock? Yes. Letter C is the best answer. This looks like a very complex question, but it's asking a very simple question. The 3 wells shown provide water for a growing city. What is the most likely effect on the system if 6 more wells, that'd be tripling the amount of wells, are brought into production as the population increases? So if you triple the amount of wells, which of the following 4 things will happen? The limestone layer will collapse. No, the limestone layer is not going to be affected. All right, don't overthink it. Maybe you're thinking the limestone layer, or there's karst topography, there's caves, there's caverns, it could crumble and sink. All right, don't overthink it. The well's not in the limestone layer. All right, the shale layer will shrink. Shale's not going to shrink. We're not going to shrink a rock layer by taking water out. The aquifer will increase in volume. So, this is tricky. Now, Will there become more water if we triple the amount of wells? No, there's going to be less water, which is going to result in J. The water table will drop. So that will be a lowering of the water table as we take more and more water out. So our best answer of what will happen if you triple the amount of wells is J. The water table will drop.